Oh, look, it's the top of the hour. My mic isn't working. Check. Are we getting sound? Okay, thank you.
I can hear you.
Thank you. Meet Echo put up a thing that said, "Are you speaking? We're not getting any sound." And I believed it. What a fool. Okay. Thank you for the axe. Here we are. It's IDR. You knew that because it's kind of hard to wander into the wrong virtual realm. Here's our note. Well, if you're in this meeting, you're somehow agreed to this thing because it was on some click wrap, and you've are presumed to have read and agreed to all this stuff. If you haven't, go read it. We have an agenda. We had, let's see, actually this is a little outdated because both of Linda's talks, number 6 is coming after number 7. Other than that, I think the agenda is as it stood before. So, Sue, do you want to talk to these?
Can you hear me?
I hear
John,
you.
am I good?
Yep.
So I sent working group status out today. I am looking for BGP LS reviewers. If you have expertise in implementation or deployment, please let me know. We have 4 BGP LS documents which have just been approved. So if you have also with virtual ITIFs, I would like to make sure I get all the adoption requests. If you've got an adoption request, please send me a note. And Yang model has received shares, comments from the Yang doctors. I'd love to know if there's any comments. I still have a couple people to check with. I will try to arrange some conversations with you one-on-one, and then perhaps you may see a short, I'd like to collect comments on the BGP Yang model so we can wrap that one up. Next, John. Next slide, John. Find it. Okay, where are we? Well, FlowSpec 5575 BIS and FlowSpec B6 are very close to publication. We're nitpicking with some of the ISG members, but that's good. We wanted to make sure this time we don't have to go back and do the version 1. It's time to begin work for people who are interested in FlowSpec version 2. Watch for a call for presentations and perhaps an interim. I'd like to kick things off on interims because this is a short timeline. The IPsec tunnels are still progressing along. I'll go through that, and BGPLS will talk about streamlining. The AutoConf work is stalled. The chairs will restart, and I think we're pretty much got one route leak protection document, and Grow and IDR are working together. Next slide, John. The IPsec tunnels. This is just a report from someone who has been trying to work with all 3 sets of authors. We had 2 in IDR, 1 in BEST. I still see 3 different use cases for these. My goal has gone down, as a sort of shepherd trying to help them, is to see if we can share TLVs, if they're the sub-TLVs, if they're the same information. But the critical thing is that they get reviewed by the security area and or security directed, so that when we come back to the ISG with them, we're not spending time iterating there. They all should be based on draft ITF, IDR tunnel and caps, and I look for clear specification. A non-goal is to force these 3 different use cases into one tunnel type. Next slide, John. And now Adrian brought us the BGPLS registries. Adrian, would you please lead this discussion?
Yeah, sure. So you may remember we had a little draft to fix up the BGPLS registry allocation policy. So this was all set up originally in 7752 as that's interesting. That's wrong. So they were all set up as specification required with approval by designated expert. And the guidance to the DE there asked for a stable document as described in RFC 5226, which is now 8174. I can't remember. So there's lots of debate about whether an internet draft qualifies as a stable document. And Alvaro pointed out that IDR is not the place to have this sort of debate. So we really have two options. Move to expert review. Expert review simply relies on the designated experts, which is what we had done in the draft question, or we could move back to specification required, but tighten the DE guidance. So I kicked the list, and very many thanks to Bruno, Les, AC, and Kitan for chiming in. And it looks like we're moving very fast to, yes, let's be expert review, but let's tighten up what the DE is allowed to do, in line with RFC 7370, which did something similar for an ISIS registry. So I think that my next actions are to bash the DE guidance and then ask the chairs whether we should wait for 7752 bis, which is on our agenda later, or push this draft back to the AD for further action.
To ask that now, or do you want to ask that after you've bashed their document?
I think the two things are entirely independent.
Okay.
That is to say that the text needs bashing, full stop. And we should now decide, given that 7752 bis may have advanced a lot closer, we should decide whether we want one or two documents.
Being at the speed at which things come in and off of the AD queue, I'd like to keep what's on the queue, then the AD can bash. But that's my single co-chair, very tactical viewpoint. John or working group, any other thoughts?
You have Alvaro in your queue.
Vero speak. John, I think you have to allow Vero.
Okay, so is it me or John? Me? Okay. Yes, I'm sorry my queue is kind of slow, but there's a lot of documents. Tunneling caps took a long time. Whatever. I have a lot of excuses. What I want to say is that I'm not opposed to two documents or whatever you guys want. What I did want to point out is that 7370, which Adrian mentioned, is the guidance for expert review for the ISIS registries. And basically what that says is that it is basically 7120, but handled by the expert review, handled by the experts. In other words, drafts need to basically be adopted by the working group before anything gets adopted. So it is pretty much the same thing you have today, except that it's a different way, right? It's a 7310 or 7370 with expert review instead of specification required with 7120. With that little caveat of maybe there's not enough clarity in different places about whether an ID is accepted or not. That is totally up to the DEs. And I know that's not documented anywhere, but I'm sure that the current DEs, which Adrian is one, and the chairs and me and Diana wouldn't be opposed to any of that. So having said that, if we're going to go with 7370, like expert instructions, it is pretty much the same thing that you have today. If one of the objectives, which is what I understood from the draft, was to speed things up and let people request code points without being working group documents, then that doesn't necessarily get you there. Now, again, assuming that 7370 is taken the way it is, it can still be modified. So just wanted to point that out.
Did you have any other comments? I think, Alvaro, I wasn't trying to say that things were really slow, but I agree that tunnel and caps took a lot of time out of both Alvaro, John, and I. It's a good and meaty spec. I'm amazed with some stuff John's done. Okay, Adrian, any more final comments? Otherwise, I'll go on to some more chair.
No,
Sure,
let's get the working group going, and I'll take this to the list.
Okay, so I'm going to go, John, to the next slide. Could you advance for me? Okay, I think you got to get one more.
I did something and now it's not advancing.
Okay.
Give me a second.
I can free range. People can read it from the rest. Why don't you try one more time?
Yep.
Okay. Okay, well, I will just pick it up from there, John. The rest of it can be fairly brief. Okay, John's gone someplace. Okay, folks. The remainder is, give me just 1 second, please. Okay. We have the AutoConf design team, and this one I hope you all will take a look at. It sort of got installed, partly many things, but we're going to give a push. I have a couple dates in December, 8th and 15th. If you're on, thank you, John, you're back. If you're on the AutoConf design team and you have strong feelings for a particular date in December, please say it. We will try to get some meetings and get an initial statement and design document out. I will probably suggest to the authors and to the working group that we hold an interim and talk about the original thing and bring a summarization to ITF 110. John, should we try for the next slide? What was that? The last one's just a big thanks to G. He's done a great job of organizing and shepherding things. We wanted to make sure to thank him. He created our agenda and organized our speakers and helped John and I stay focused on the tunnel and cap spec. Thank you. John, I think we should go to our first. Any comments, folks, on any of the points in the chair slides or the status? Seeing no comments in any of my things, we're going to go on for the first section. It's draft IDR segment routing TE policy.
Hello, am I audible? I think so. Okay. Hi. Can you hear me?
You sound fine.
Okay.
Just
So this is a update on the segment routing T policy. So BGP signaling of SR policies. Next slide, please, John. Just a quick overview. Not going to go to all the details. So this was presented a year ago now, and we have had feedback and inputs, a lot of discussions on the list as well, and all of those have been updated or captured in this update. Quick point that the base spec in Spring, which for which the BGP extensions are covered here, is also kind of getting ready for working group last call in Spring. Next slide. So what are the updates over the past year? That is since the last presentation. There have been changes to align with the SR policy architecture, the base draft. There was some confusion about the policy name TLV that was there existing, and that was actually the SR policy candidate path. But then based on requirements and requests, we also added the policy name again for alignment with the SR policy draft. Discussion about the route origin community and its usage to indicate the originator. So we've added that in the draft. And then we'll go about the changes related to SRv6 in the next slide. But other thing I would like to flag quickly is we've seen the tunnel NCAPs draft, getting fixed up, and as part of that, the IANA registration is happening there for the color extended community. So this draft has now been updated to refer there, and the IANA section text has been updated. There are other fixes and stuff. Again, thanks to everybody for pointing it out. Next slide, please. So about the SRv6, the network programming is, with the ISG awaiting, last discuss. But what we did over the past year is, updated to align. So we have a SRv6 binding SID TLV. And this is because the current binding SID TLV, we could have only one binding SID associated with the SR policy. But when we get to SRv6, we can have more than one with possibly different behaviors. So all that clarification and text has been added, and the segment types have been updated for the optional signaling of algorithm behavior, things like that. So that segment type changes, what it has resulted in is that the previous type TLVs, we've had to deprecate them. We had a check with some of the vendors, and whether they're deployed and used and all, and we got the indication that they may not be implemented or deployed fully as yet. But just to be safe, the proposal is to deprecate them. They are kept in the appendix, so look forward to feedback from the working group on this one. Next slide, please. So next step is, I would say, preparing for the working group last call. The implementations have been updated with 2, but we're aware that there are more, so I would request to please update. And I think it would be good if we can plan a working group last call for this, preferably after the base one is done in Spring. Any questions or comments, feedback?
Looks like we have a comment from G. Please go ahead.
Can you hear me?
Yes.
Yes.
Hi, G.
Hi. Regarding this change in the segment types, there's also a draft on the TLSP distribution to report the.
Yes, I think we need to.
There's
Yeah, you're
also a
right.
list of the segment types. Maybe there needs some alignment or simply
Yes.
reference this one.
Yes, you are correct, G. I think we need to work on that as well. We'll work on that. I mean, you are also the co-author there. We'll work on that offline.
Yes.
Yeah.
Yes. Okay.
Thanks for bringing that up.
Okay. Seeing nobody else in the queue, I guess we can move on to our next one.
So this is an update on the RFC 7752, the BGPLS BIS that Adrian referred to earlier. Next slide, please. So we have had since the RFC publication, and even before that, we have had a lot of implementation and deployment now with a lot of use cases. And there has been a discussion on the list, as well as a lot of inputs from various folks, including our AD, when he was reviewing some of the segment routing extensions, that there are issues. So we started around IETF 104 this thing to try to fix them up. The draft was presented at 105 a little over a year ago, and then it was adopted. So it's been a year now, more than a year. So I would like to thank everybody again for a lot of feedback and input. A lot of it on the list, but there was also a lot of off list comments. Next slide, please. So we have tried to capture, as editor for the working group, we have tried to capture everything in all those inputs and comments. I didn't want to go over all of that, but I would like to point that the appendix has list of all the changes from the base 7752. It's like a kind of a summary. And then actually you could run a diff. There's a link there to check what has actually changed from the base spec as well. I'm hoping that this helps the working group actually go through review and make sure that everything is okay and we are done. Next slide, please. So INR considerations. We discussed. There is a draft that it's in AD evaluation. Whatever gets updated or accepted there, will also incorporate that here in this draft. Personally, I think that it is required or good to progress the BGPLS registry draft as a point fix RFC. It would go through much faster. So that's just my preference, but we'll look for working group. Next slide, please. And this is the last one. Really, all issues and all concerns have been addressed. Please let know if anything was missing. I know it was a difficult time over the past 9 months this year, but in case you wanted to, so there was a bit of silence, but if there is anything else that needs to be added, please do let know. I'll also poll the list after this meeting. Last slide, I think, is the next one. So how do we go about this, and wanted to check here whether we need to keep this BIS document open. If yes, for how long? If no, then maybe next year, early next year, we start planning for a working group last call, because I'm not sure if helps just to keep the document open. I'd look to inputs from the working group chairs as well.
John, I'll jump in here real quick. I always find that a working group last call knocks out comments to documents. So I'd go for December or January for working group last call whenever you finish the other things. John, do you have any other comments about that?
I was just going to give my answer to the do we see a need to keep the biz document open for more time? And my answer is if you feel it's done, then I don't see a need to keep it just arbitrarily open. We need to have a proper working group last call and know that some people have reviewed it. But beyond that, no, let's get it done. I mean, if anybody else thinks otherwise, please put yourself in the queue. But I'd say, yeah, what Sue said, let's go ahead with the last call fairly promptly. And I see Adrian volunteering to review. Thank you, Adrian.
Yes, thanks, Adrian. That's all.
And unless there's anybody else who wants to put themselves in the queue, I think we can move forward. Donald.
Okay, hi, this is Donald Eastlake with FutureWay. That's what I want to do. I'm going to present on flow spec for tunnel traffic. Next slide, please. So the file name for historic reasons has NVO3 in it, but it's actually designed to cover flows for a wide variety of tunnel types that are listed there. One's currently in the draft. Will be possible to add more, I suppose, but I think it's got a pretty good covering. And it allows you to match on the actual tunnel header fields of various sorts, as well as the various headers that are just beyond the tunnel header. Typically IP headers just beyond the tunnel header, could be other things. And you can as well match on the IP or whatever header in front of it. There'll be examples and stuff in a little bit later in the presentation. And you indicate all this with a AFI-SAFI pair, using a new SAFI that indicates it's a flow spec for tunnel traffic. And the AFI indicates what you're going to match right at the very beginning of the packet, or the beginning of the packet inside VPN if it's a case where you're matching VPN traffic. So, for example, you might have a IPv4 AFI, but this AFI says tunnels. That means you matched an initial IPv4 header, but then you would be able to match various forms of following that tunnel header. And if you want to go beyond that and match the headers just beyond the tunnel header. Next slide. So this is just how this depends on other drafts. And I annotated this with what I believe is the current status of the different slides. Next slide, please. So this has been changed. The last presented version was 08. So 08 to 09, there were changes in the precedence rules to clarify things. Obviously, only when a tunnel flow spec is involved. The existing rules cover other cases. And various editorial improvements and typo fixes, particularly the two noted there, which occurred multiple times. Next slide. And then there's changes from 09 to the currently posted 10 version. The L2 TPv3 flow spec in there was extended. Previously, it was good for data messages, but it didn't really cover control messages. So that involved one fairly small addition, sort of expanding the capabilities for that particular tunnel type. And the second point here is the various fields which were added for matching purposes to handle control messages and for further editorial improvements. Next slide. So this is kind of the heart of the thing. So what the NLRI looks like. So you have the overall length, and then there's the tunnel type. So if you have to have a tunnel type if you're using this. It's only for tunnel traffic, and it only matches tunnels of that type. There are two flags. One indicates whether or not there's a routing distinguisher present because you want to handle a VPN case. And the other is whether or not there's what is called an inner flow spec. So moving down, then there's the outer flow spec, and that's matches an outer header, which type is determined by the AFI, for the AFI that invoked this parsing and interpretation. Then there's the flow spec for the tunnel header itself, which it could be extensive or it could be minimal, depending on the kind of tunneling. And then if you've indicated it's present, you can have an optional inner flow spec, and you have to provide another AFI down there for that, because you need to indicate whether you want the inner flow spec to match, for example, IPv4 or IPv6. Next slide, please. So here's a simple example where there actually isn't anything to match in the tunnel header. It's IP and IP. So you have that's the outer and an inner flow spec if you wanted to match across those things. You wouldn't, you initially be matching probably the IP header, but if it was in the VPN, you might want to match an initial L2 header. Next slide, please. This is a slightly more complicated VXLAN case. In this case, there is the VXLAN header. You can match fields in there, and similarly, there's an outer and inner flow specs. And in this case, the inner flow spec would be optional. You might want to only match outer and some fields in the VXLAN header, like the VNI or something, and not match anything on the inner header. So that is basically how the tunnel flow spec works. And next slide, please. So believe that this draft is ready for working group last call. We're going to see what comments there are here at this meeting, and perhaps over a short period of time, and maybe do one revision and then do working group last call, perhaps. I see Jeff in the queue. I'm happy to hear what he has to say.
Yeah, please go ahead.
Hi, can you hear me?
Yes.
Yes.
Hey, it's Jeff. So Donald, we've gone through a lot of learning as part of working through the 5575 BIS stuff. You are doing this as a new AFI-SAFI pairing, so this is effectively ships in the night versus the other spec. You really don't have any real dependencies as far as that piece is concerned. The thing I have to ask, though, is that since you're sort of leveraging existing encoding types, you know, in terms of like the op fields as an example, that means that as you're specifying things, you're vulnerable to one of the interesting extension headaches that we found for 5575. So basically, since there's no, yes, go.
I was just going to say, okay, this draft says that for the matching the headers, which is the really new, substance to be matched, that there's a separate registry, and I believe it says that they are all TLV format. So it doesn't say anything specific about what to do about unknown types, for example. So maybe that's something that should be clarified.
Possibly, and I'm also realizing that I was looking at version 8 rather than version 10, where I see you've actually made a bunch of changes. So I think I think I have to withdraw my comment.
Well, okay. I think it's looking at it from the point of view of extensions in the future. For example, a new tunnel header type is something useful to do.
Okay, I will re-review based on the current draft. For some reason, I had it as stale cache.
Okay, thank you.
Alvaro.
Hey, Donald. I have a
Yes.
quick question, just to see if I understood what you just said to Jeff. So what you're doing is the encoding in the NLRI of the operators, right, and the components to match is now TLV based.
Yes, yeah. Essentially, the fields being matched are all either like value fields or fit fields or something like that. So the existing match operators and way the value to be matched is encoded, and the logic of having multiple of those and the anding and oring is sort of all the same, but they're, I believe, they all have type and length at the beginning, and so even though the value encoding is copied from earlier documents, and they have it's a new registry with types that can't conflict.
Right.
So.
Okay, so I have a question not for you, but maybe for the chairs. Well, we were doing 5575 BIS and the V6 flow spec. The answer to a lot of the questions about extensibility and other things was we're going to be working on flow spec V2. Now, it seems that 5575 BIS, this solution, and flow spec V2, whatever that is, may all be three different things, like ships in the night, right? Is that what we're talking about? Is that the direction we're going? Am I completely confused? Do I need to go to sleep? All are possible options.
I need to go to sleep. Sue, do you want to take this?
Yeah, I'll take this. So Alvaro, you've hit a point that I was going to raise anyway. Here's our challenge working group. This draft was adopted before we got into the understanding of how much TLVs are problematic. I was hoping that Jeff had read the most recent version. I think I need to do a call before we do a working group last call that says, should this go, are you feeling an urgency to do this now, or shall we wrap this into V2? And I think I need to see what the working group wants. John and I specifically limited the first three things to what the operators told us, which is 5575 BIS, V6 because the ISG strongly wanted it, and so did the operators, and the OID because the operators wanted it. I would love comments now. We also can take comments. John, should we take this to the list because of time, or shall we allow?
Our time is okay for now, so let's
Okay,
go ahead and let
so
the conversation go.
I'd like some feedback. Should we delay this to? Are the operators waiting for this, or as I've announced, it's time to start V2? Shall we put this in V2? This document with what Donald's done starts to have all the TLVs. We don't know if there's any problems. It's sort of going toward that direction. Feedback working group.
Jeff, please go ahead.
And that was my call for feedback. Anybody want to make any comments now? It may be early.
I'll make three very brief ones. The first one is, do we want to going to fit on flow spec as V2? That's an open question. We could certainly. I think the interesting question that drives that more than do we have to do it just for your niceness of encoding, is really whether or not use cases for this draft are intended to overlap ever the stuff in the existing flow spec documents. Because then what you would end up having is basically firewall rules that in one case deals with the tunneled stuff, and then you have a different case of overlapping with the existing use cases. If the two are intended to be mixed at some point, having them as separate AFI-SAFIs is a little weird. If it really can live as ships of the night, even if it's just temporary because of a strong need for the use case to be deployed, nothing stops somebody from shipping, basically this version of the draft to cover the use case, and then we end up with flow spec V2. We end up with a merged form. That's my comment.
Thanks. Any other comments right now?
Show of hands thing, see if we can get some sense.
Can I make a brief comment? I just wanted to say that I think that a working group last call would cause greater working group attention and review of this document, and that would perhaps yield something which could have better expressed the need, what the actual requirements and an adequate mechanism would be. Certainly the flow spec needs, as indicated by this draft, should be one of the inputs to the V2 effort, I would think. That was my comment.
Okay, Donald, so you feel like I've any other comments from other people? John, do we have people in the mic queue?
We do not. I think that we can move on and discuss this on the list. And I think that, Donald has a valid point that a working group last call is often a good forcing function anyway. So if we want to discuss it in that context, I think it would be reasonable.
Yeah, we'll start there, but I'll put some details in the working group last call regarding FlowSpec V2. And
Exactly.
sounds good. Okay, John, I think, Donald, anything else you'd like to say about the working group last call?
Nope. I'm in favor of
Okay.
it. But other than that, I'm for it.
Thank you.
Hello, everyone. Can you hear me?
Yes, we can.
Okay, thank you. So today I'm going to talk about the updates for the RPT draft. Next page. So first, I should say thank you very much for all the people who give lots of comments around the working group last call. So especially Robert, Donald, Keaton, and Jacob. So after we receive those comments, and then we update the document, and then address. We address those comments. So those comments can be classified as three groups. One group is that we already have configurations we can for dynamically adjust the traffic. We can do this job through configurations. So why do we need RPD for dynamic traffic adjustment? So that's the one group of comments. So another group of comments is that, so in the old document, so it looks like that the RPD routes is distributed through P2P or P2MP. So in this latest document, so we update and with more details. So from this latest document, we can see that the RPD routes is distributed P2MP, is not P2P. So the third group of comments is about the issues, about failures. So when failure happens, so what happens for this kind of traffic adjustments? So we address these three group of comments. We already addressed these three group of comments in the document. Today we just briefly talk about how we address these comments. Next page. So for operational network, so we already have tons of configurations. So in order to adjust traffic dynamically, so we can use configurations. But if we use configurations to dynamically adjust the traffic, so because we already have tons of existing relatively stable configurations on number of nodes in the network, for example, we have tons of configurations on node A, and then we have tons of configuration of node B and so on. So in order to adjust the traffic dynamically, as soon as we want to adjust the traffic, then we need put or push some configurations to some of the nodes in the network, because this adjust of traffic is dynamic. So the frequency maybe sometimes high, and then so this kind of configuration change on some of the nodes of the network will be very sometimes frequent, and then sometimes maybe not that frequent. So with this kind of operation, so change configuration on some of nodes and then delete configuration on some of nodes, for dynamic adjust traffic will have some issues. For example, this kind of operation is very complex and error prone. In addition to that, this kind of dynamic, we have stable configuration and then we have dynamic configuration keep changing. So this is hard for operators to maintain this kind of things. So with RPD routes, and then these issues or problems is resolved. So that's the reason we use RPD. Next page. So another group of comments from the last call is that people say that this kind of RPD routes distribution is P2P, and even though they can be a P2MP. So we address this one. So we through updates document with more details, and then through these updates, so we can see that RP route distribution is P2MP, is not a P2P. So here we show a typical application scenarios. So in this network, we have one AS, AS1, and then we have another two AS, AS2 and AS3. So here we have a controller, and the controller is connected to a router reflector. So this router reflector is connected to all the other nodes. So here we just show the nodes A, B, and C. So in order to adjust the traffic dynamically, so we just let controller send RPD routes to router reflector. Then router reflector reflects those RP routes to all the routers. Here, for example, the RP routes will be sent to A and B and C. So this is a P2P, is not a P2MP. So after each of the routers receive this RPD routes, so it will apply the policy included in this RP routes to the routers or accordingly to the peers. Or, for example, we can apply those policies controlled by the peer IP address. So if a peer IP address is 0, then that means we will apply this policy to all the peers. So if this peer address is determined is not 0, that means we just apply that policy to that peers. So in fact, this peer IP doesn't change the P2P behavior of a traditional BGP. So next slide. So the last group issue is about failures. So the failures we can classify different types. One type is that the failure is because of bug. For example, failure, the router is failed. We cannot, or a route fails to install the routes in the forwarding table. So this is out of our control. This is the bug. So we need to fix this bug. So this failure issue caused by this failure is out of this document. So another failure is that we can have controller failure. We can have a failure of sessions between the controller and the router reflector. So for these kind of failures, so we can use existing GRs. So we can use the basic GR. So in this case, either controller failure or session failure, and then those of routes for used for adjustment traffic can stay there for some time. So if we think this time is not long enough, so we can use long-lived grid restart. So in this case, we can keep that route for adjusting traffic longer. So in worst case, so even so we use this kind of grid GR, try to keep the route for adjusting traffic get withdrawn. So in this case, the worst case is that even though this grid restart doesn't work for this case, we fall back to the original routes. That means we try to use RPD routes to adjust traffic to the best routes, we think. But because of failure, the routes for adjustment get withdrawn, then those traffic will fall back to the original path. So I think that this one, even in the worst case, I think is acceptable. Just that this route for adjusted traffic doesn't take effect. So next page. So we would like also get comments after we address the existing comments.
Man, anybody have comments? Okay, well, questions and comments on the list then, please. Thank you.
Okay, thank you.
Yali, please go ahead. Yali, if you're speaking, we can't hear you. Yali, sound check. Still can't hear you. Yeah, I think Ji's suggestion is good, and we should move on to the next presenter, and Yali should work on audio in the meantime, and we can come back. Okay, so we're going to switch. We're going to continue to the next talk, and then we'll come back once Yali has audio worked out. So next presenter, please. Wait, do we have sound from Yali?
Oh, hello. Hi, Joe.
Hello. Yes, yay.
Oh, yeah, I have some problem.
Good to hear you. Okay, please go ahead.
Okay, thank you. Sorry for that. Okay, this is a draft about the IFIT capability and advertisement. We have defined extension to BGP protocol. Next page, please. Yeah. So in this draft, we mentioned the IFIT word to refer to the family of the unpassed telemetry techniques. We include in this terminology has the IOM and the alternate marking method. And we also considering the IFIT domain. It means that the performance measurement domain. So from the security consideration side, to avoid the IFIT data leakage outside the domain, so we need to make sure the IFIT decapsulating node, that is the tail node, must remove the data field. So that's why we extend to the BGP protocol to advertise the IFIT decapsulation node capability to the head node. So taking this extension to BGP protocol, the head node can collect the information to know whether the tail node can support the specified IFIT capability before insert the IFIT command into the traffic packet. So from this motivation, we define two options in this draft to make the extension to BGP. The first of all is the extension to IPv6 and IPv4 address specific extended community. And the second option is to extend to the BGP next hop capability. Yeah. Next, thanks. So from first of all, we need to define the IFIT capability. What is the capability? So here we mention the format field we defined in less draft. Here we see this is a 16-bit bitmap field. It includes the 5 options bit to indicate which kind of the performance measurement method can be supported at the tail node. It includes the IOM and the alternate marking method. And next, thanks. Next slide. Yes. So here is the option 1. It is the extension to BGP extended community. Here we are considering to extend to the IPv6 and the v4 address specific IFIT extended community. We're considering this is a transitive optional extended community. So we can use this to notify the IFIT capability to observe the tail node to its partner. I mean the IFIT encapsulation node. So here, from this 2 figure, we can see that the format, and in this format, the optional IPv4 address and the v6 address is the address of the IFIT decapsulation node. Yeah. Next page, please. So yeah, this is option 2. It's extension to the BGP next hop capability. So as we see the working group draft defines the BGP next hop capability, it's a non-transitive BGP attribute. So we can consider use this in the intro domain. So to notify the tail nodes capability to the head nodes. Here we also define the format based on the working group draft, defines the next hop capability, and we extend to the IFIT capability include in the capability value field. Yeah, and next, yes, yeah, this is all the content defined in this draft. And any questions and comments? Thank you.
Thanks. Any comments? Okay, queue is empty, so let us continue. Thank you.
Thank you.
Please go ahead.
Okay, thank you. I'm Yao Liu from ZTE, and this draft is about the BGP extensions of the SR policy for end-to-end path protection. Next slide, please. When SR policies are involved and a strict compliance of the SR policy is required, an end-to-end protection should be preferred over a local repair mechanism. It is introduced in the SR policy architecture draft that candidate path can be used for path protection. And SR policy allows for multiple candidate paths, and only one active candidate path can be provisioned in the forwarding plane at the same time. So other lower preference candidate paths may be used as a backup path. When distributing SR policies using BGP, each candidate path is carried in an MLRI. So far, there is no mechanism to carry the protection relationship of candidate paths in BGP advertisement. And of course, we can do it by local configuration. And backup candidate paths provide protection only when the segment lists in the active candidate paths are invalid. It is not flexible enough in scenarios like load balancing. For example, candidate path 1 is the active candidate path, and the flows are load balanced between segment list 1 and 2. Candidate path 2 will take place only when both segment list 1 and 2 are invalid. If we want to protect segment list 1, so flows can still be load balanced between segment list 2 and the backup path after segment list 1 failed. Using candidate paths for protection cannot achieve that goal. And this document proposes extensions of BGP in order to provide path protection use segment lists when delivering SR policy. Next slide, please. Segment lists can be used solely or combined with candidate paths together for path protection. This figure gives an example. The Heliad node has received 2 candidate paths belong to the same SR policy, and CP1 has the higher preference, so CP1 is chosen as the primary path. And in CP1, list 3 is a backup list, so it will not be enabled on the data plane at first. After list 1 failed, list 3 will take place. If list 2 and list 3 are both invalid, then CP2 can be enabled for protection. Next slide, please. Here are the BGP extensions for SR policy proposed in this draft. And the B flag in segment list sub-tier V indicates the segment list acts as a pure backup path in the candidate path. And list identifier tier V is used to identify the corresponding segment list. And it contains the optional sub-tier V, list protection tier V, which carries the protection relationship of segment lists. The rightmost figure shows the position of the newly defined tier Vs in the advertisement of SR policy. Next slide, please. And in the TLSP distribution draft, they could describe a mechanism to collect the policy information that is locally available in the node and advertise it into BGPLS updates. And it includes SR candidate path state CLV and SR segment list TLV. And the SAB flag are originally defined in candidate path state TLV, while the S flag indicates the candidate path is an administrative short state, and A flag indicates the candidate path is an active path, and B flag indicates the candidate path is a backup. And two new flags are introduced in is draft in SR segment list GLV to offer more details of the segment list states. And the S flag and the B flag has the similar meaning. And the S flag indicates the segment list is in the administrative state, and the B flag indicates the segment list is a backup part. And next slide, please. And we request feedback and comments. Thanks, that's all.
Ketan, please go ahead.
Thanks for the update of your draft. What I would suggest is some of the proposals here, like having a primary and backup semantic within segment list of a candidate path. I mean, this isn't something that is covered by the base specifications in Spring Working Group. Also, this notion of primary and backup candidate path, that is something which is covered to some extent. But then there is also the way candidate path selection happens. What I would recommend is that please get the work reviewed and hopefully adopted in the Spring Working Group before adding protocol extensions for it. It's just a suggestion.
Yeah, and
Okay. Thank you.
I was going to make a similar comment, which is that the proposed encoding seem fine, but the underlying idea seems like it's something that Spring should review at least.
Okay, I'll take the comments and send to the Spring for review. Thanks.
Great, thank you. Any other comments? If not, then we will continue forward. Linda, are you here? Yes.
Can you hear me?
Yep, loud and clear.
Oh, good. Okay, so here we want to propose a new path attribute in the BGP NRI called app metadata. The purpose is for 5G edge computing service. Next page, please. Okay, so the purpose is to, for the 5G edge computing, be able to propagate the running status, including environment, including site prefix, site preference or capacity, into the ingress router for them to make intelligent decisions to achieve optimal performance and the user experience. Next page. So a little bit background. 5G edge computing is a project in the 3GPP SA2, and this is defined in the TR 23748 for the release 17. They have identified many use cases. For example, drone communication with controller. They require backend servers to be very close to the device, and also they require multiple servers for the same applications. So you could have 5G sites and each of the cell tower to have this backend server hosted. And they have virtual interactive conference. All those use cases being identified there all have the requirement of the short delay. So one of the characteristics of 5G system is the sites are very close in proximity. So you can have one site, like you have a bunch of UEs, user device, anchored into PSA. PSA means packet session anchor. And they go to the local data network. And you could have another PSA2 in very close proximity. So for the server, backend server, you could have multiple copy of them very close nearby. Next page, please. So from IP perspective, right, we are working on the plumbing from the networking side, the IP layer. More and more, the trend is to use Anycast address to represent all those duplicate servers, not duplicate, multiple servers for one application. Anycast have lots of advantages, but traditionally have been used in many like far away geographic locations. So the benefit of Anycast is really for network to expose, to utilize or leverage the network routing layer to help application to achieve better performance and to eliminate the single point of failure of the local DNS resolvers or the application load balancers. And also many clients in the fixed network or in the mobile network UE tend to use their cached IP addresses for extended period of time. So even if you have local DNS resolver in each of the local data network, UE, when they move to a new location, they may not resolve to find a new IP address. So the benefits are great, but they also bring a bunch of issues. One of the key issues is when all those servers are very close in proximity, the routing distance, routing cost can be very small. And it's smaller than other factors. For example, in this example, you can have EAS meaning Edge Computing Application Server 1 in local data network 1 has high capacity versus EAS 2 in LDN 2 is overutilized. So when the UE moved to anchor to the PSA2, the performance, overall performance will be better if they are still served by the original EAS1. So the many factors affecting where the routing is. Another issue that quite different bring in by this edge computing is from the PSA2, the packet session anchor 2, there could be many UEs already anchored there, and they using their local algorithm to choose the right edge server, maybe EAS2. But when the UE1 move from the anchored PSA1 to PSA2, they better service will be provided by EAS2. So same destination, same address, the performance can be based on different source can be different. Next page.
Sure. Linda, do you want to take questions interactively or hold them till the end?
Sure, if it's not too long.
Casey, go ahead.
I'm just wondering if it's an Anycast address, how do you bind a UE to a server, because you don't want it to, assuming there's state associated with the UE.
Okay, so you mean that when the UE moves to a new location, how do you bind to the original
I mean
one?
if you're dynamically load balancing, how do you pin a UE to an app server if it's an Anycast address?
Okay. So in today, especially if you look at IPv6, right? They have a flow label. So many today's routers support putting all the flows, all the packets within one flow into one path. Okay, that's one criteria. Later on, I can explain some of the criteria for the put into the ingress router so that they can guarantee that a packet belonging to one flow always anchor into one particular instance of Anycast server.
Okay.
Why?
I'm assuming you can hear me.
Yeah, I can hear you now.
Okay, good. I don't know, Linda, if it helps. I see that your I mean, I see one slide that talks about within a market. I see another slide that talks across markets. And I know you're trying to kind of represent the IP network, but I don't know if it helps if you can draw out, the DU, CU, UPF, because, in the old days, that was all, backhaul. Now between front haul, mid haul, and backhaul, when you call an IP network, I don't know which area you're talking about. So maybe if you do, you might clarify it better.
That's a very good comment. If you bring back to the first page, previous page, John, if you can bring up the previous page. So in this network, obviously from the base station eNode B to the PSA, that's within 5G system. So they have IP network as well. There's a draft in the DMN on the TN aware mobility about network within the 5G. They have IP network. Here I'm talking about a local data network after the UPF. So UPF and PSA is a function of the UPF, user packet function, right? UPF. So the LDN, local network data network, is completely IP network outside the 5G. It's serving the 5G system. Okay, so maybe later I can refine the description, maybe in the draft. Hopefully, people can give more comments.
Should we move forward?
Is that clear, Lua? Okay.
I guess he'll put himself back in the queue if it's not.
Okay. So this page is about in the 5G edge computing service, to select a particular edge server. Traditionally, Anycast is purely based on the network routing cost, right? But in the 5G edge computing environment, for example, S1 here, they are in 3 different locations, we call 3 different local network. And the network routing distance, maybe there's difference. The round trip time may be a little bit different, but there's other factors. For example, S1 could be a bigger capacity. S1 in LD1 could be bigger capacity. Could have multiple servers behind a load balancer than the S1 in the LD3. There could be a site preference, like network capacity preference. For example, in the R1, that's like a mini data center, the capacity there is much higher than the capacity next to the R2. There could be that for particular UE1 that he actually initially anchored to PSA1, UPF1, and go to the LDN1's S1. When he moved to the site B, which is maybe very close to each other, the capacity overtaking the network delay. So quite a few different factors for the ingress router to consider to choose optimal Anycast location. That's why we want to introduce some matrix for the egress router, R1, R3, R2, to propagate it to the ingress router, which make decision in forwarding. Next page, please. Okay, so here is why we need this application metadata. So this is a new path attributes, which include load measurement, meaning for each of the egress router, which have the application servers directly attached, be able to do some measurement on the traffic flow to and from the server. There is a capacity index. This capacity index can be pre-configured or could be learned based on historic data. And there is a site preference. So the site preference can be dynamic based on who is accessing it. Depending on different UE, the preference could be different. So with all those combinations added together, the ingress router can make intelligent decision In the draft, there's we give an example algorithm on how the ingress router utilize different attributes to compute the index to choose which site to use. There's also other factors to be considered. In the RTG, there's a draft on the make it transport network transport aware mobility. So basically that draft is about within the 5G, that GTP tunnel, they use UDP port range to represent different priority or different slicing of the network. And those information can be passed through the 5G network exposure function to the local IP network. And that information can also be carried by the BGP's app metadata TLV to pass to relevant routers. Next page, please. Here is the load measurement. As a router itself, we most likely applications are encrypted. They don't give us information about the internal logic. And from the plumbing side, we can only see the packets going into the router, going to the server and coming from the server. And from historic data, an analytic tool will be able to measure like this particular hour's traffic amount is much higher than the historic ones, or much lower than the historic ones. And also the delay from the response, compare with the historic data through some kind of self-machine learning algorithm, be able to figure out that whether the server is overloaded or underloaded. Of course, that is all out of the scope of this particular working group. For IDR's BGP, we just want to be able to carry this information. Suppose the router, egress router, have the information. So for load measurement, so far we define two types of load measurement. One is the raw measurement. The raw measurement can be useful for analytic tool. Like suppose there's an analytic tool attached to the raw reflector, and that needs the raw data for future prediction. Another matrix to be propagated is aggregated index, so that suppose all the routers belong to same provider, they can have the same algorithm. For example, here, kind of weighted about all those different measurements. They added weight together to come up with the aggregated load index, and this index being propagated to the ingress router. Next page, please. Next page.
Yeah, I need a sec here. Something went wrong with the PDF viewer again.
Oh,
sorry.
Okay.
I'm going to unshare my screen and then reshare it. That finally is what ended up fixing it last time. Okay, one more second. We'll be back in business.
So when you're working on this slides, I just want to mention that there was a side meeting on the Compute First network. That is assuming that application server, the computing services can expose the internal logic to the network, and having the routers in the network to be aware of the computing resource being utilized by different app server and be able to forward it appropriately. So those kind of information can also be carried by those app metadata pass attributes. Of course, they may introduce some new sub-TLVs to indicate the detailed attributes exposed by the app server. So here is the capacity index. So the capacity index is just a value which can be configured or can be learned through the past history. The preference index is actually referring to specific applications, application servers, and that is also can be configured and can be can have the configured algorithm to calculate the preference index. Okay, next page, please.
Before I flip, would you like to take AC's question now?
Sure.
AC, go ahead.
Hey, Linda, I think you need to, I mean, it wouldn't be the only way to implement it, but I think you need to specify how this forwarding plane, like a reference model for this forwarding plane that you're envisioning. You can't just wave your hand and say IPv6 has a flow label. So at least in one of these drafts with all these metrics, you need to have that with the all the Anycast, reachable Anycast destinations, and at least one reference on how you would envision this working, because I don't think anything like this exists today.
Okay, I will add the section on that.
You know what I'm talking about, right?
They support flow-based forwarding. Okay, I will add that. Thank you.
And we have a couple more in the queue, so you want to keep taking those? Boris, please go ahead.
Thank you, John. Linda, one question. I'm a bit worried about, is BGP a right like transport or tool for sending load measurement information? Because information about particular load of this egress node will be delivered with delay, right? Propagation handling delay. So it will be information about load in the past. And my concern is about how actual this information will be to make decisions about.
Okay, that's a good question. So here we're not talking about transit measurement. We're talking about historic measurement. So you're talking about, like, for example, last 24 hours measurement versus last 1 hour average, and or last 1 month average. So it's not about very transit. So the goal is really to estimate the load measurement compared to the historic data. So here, I'm just not giving the specifics on how actual measurement could be done. It could be that, like in the compute first network, the server themselves be able to expose that. They could use other information, maybe Geneve header, to be able to expose the internal requirement, a desire. So that is not specified here. Here, I'm just saying that when those information becomes available, need to be propagated. I'll take AC's comment and give an explanation. Just assuming certain, like a reference design, like how the flow, basically how it will work in the next revision.
Okay.
Loy, please go ahead.
I'm guessing you can hear me. This is just semantics, it's not technical, but you started with saying edge compute, and I see multiple IP networks. You gotta think about what qualifies as edge. If you go across multiple ISPs and you're all the way across the line, is that really an edge compute? So I think it's semantics. I know I looked at it, some pages I see where it's edge compute, some pages I don't know if that could be called edge compute. So that's just for your reference as you look at it, if you want to look at it.
Okay, I'll clean up the draft. This is 0.0 version, so thank you.
All right, let's continue.
Okay, so in terms of propagation of the app metadata, we could use the RFC 4684, the RT constraint distribution, only distribute the information to the relevant routers, because if you look at edge, those services like edge servers, they are not everywhere. and also that not every ingress or PSA would have the user device interested in those services. So the distribution doesn't have to be broadcast to every router. Since there are much more numbers of edge servers, application servers than like RT constraint being meant for the routers. Another alternative is to create this app server bound group. So this group can be statically configured or can be each ingress router can ask for the network controller who are the ones interested in this particular service. Also need a time to live, because for any service, the time, if there's nobody inside anchored to this PSA is interested in that service, then that ingress router to the local network doesn't have to be receiving the information about the specific app server as well. So this is just about the scope of the propagation. I think that's it. Next page. Oh, here is about another unique feature that our IP network can provide better than the DNS server can do. We call it soft anchoring of Anycast flow. Next page. So this is referring to this particular specific requirement by the 3G edge computing. So for app server, for example, app.net, right? App.net has servers located attached to R1, R2, and R3. What they want to do is my preferred location maybe is at R1, like for the app server. And but if something fail, either server fail or either the server is overly loaded or something happened, I want the service to go to E2 or E3. So in networking, we have done a lot of protection, right? This is can be achieved by assigning multiple addresses into one app server. We can achieve we call soft anchoring, because it's not specifically anchored to R1 or this app server. The way to achieve that is we create, for this app.net, we create a group of Anycast addresses. G4 being the address which not relevant to the location, it's not location preferred. L1 address is preferred to be anchored to R1. L2 address is preferred to be anchored to R2. L3 address is preferred to be anchored into R3. So with different cost, and the network can be able to consider all the other costs, like network delay, there could be site capacity index, some other information, all consolidated together to make the intelligent decision. And when the, like for example, if it's anchored to R1, if something fail, and then they will be equally distributed by R2 or R3, depending on the other factors. So that's, I think the network, the IP layer can provide a very elegant solution than the DNS solution. Okay. I think that's it. The background information is about how do we, it's just example algorithm in choosing appropriate egress router for the Anycast location. That has more discussion in the draft. So it's just the information here. I wish we have more discussion on the mailing list or from people here. Thank you. We don't expect to be very dynamic. We expect to be hours or days. Those are the average. That's something we expect. Or better, if the provider actually owns those applications, then they will be able to give the information directly, and that will be more accurate. Okay, so if you look at, there was a talk at the NANOG a couple of NANOGs ago. They talk about using Anycast to provide for all their services. They talk about like they can change the cost, they can change the peering policy, but they're talking about in terms of months. The traffic pattern can change. So that's with the manual intervention. So with this approach, the egress router dynamically measure the packets, and the adjustment can be in hours or minutes or days, much faster than manual reconfiguring the cost or reconfiguring the peering to better balance the load to distribution to the Anycast servers.
Hello, can you hear me? Does it work? Okay, I'm still unclear about a couple of things. Could you clarify who is taking the decision? Is it the ingress router, or do you have a kind of intelligent controller which is pushing to the ingress the appropriate route? What is your decision model here?
Oh, okay. So John, maybe it's easier if you flip to the next page, the background information on the sample algorithm proposed for the ingress router.
The main question I have behind is what is the impact on the existing BGP decision process?
Oh, so the decision is made by the ingress router. The ingress router receives all the cost from different egress routers, and he can use his own algorithm to determine which egress is the right one for the particular flow. And
yeah,
here
but this is BGP. You cannot use your own algorithm. You have to be compliant with the existing BGP decision process. So of course, you can specify a new standard which is taking into account additional parameters somewhere in the existing decision process, but you cannot simply do something else.
Wait. Let's go to the next page. Let's go to the maybe second or third page showing that the network structure. The first page, maybe. Okay, yeah, this page. So the goal of this BGP is to distribute the information. Once the information is distributed to the ingress router here, and today he used BGP to choose appropriate egress router. That's all true. But in this 5G edge computing environment, the ingress router is part of the UPF or PSA packet session anchor, and he will not only just use the network routing as the only criteria to choose the egress router. He has to consider other factors because different.
I completely agree with you, Linda. My point is just because you are using BGP, you have to comply with BGP, which means that you cannot simply override the current decision process. You can insert something into the existing decision process, but you cannot bypass it completely. Otherwise, you have a non-compliant BGP implementation. And if it's the way you want to do, simply don't use BGP and write your own protocol. That's also fine. But my point is just, if you use BGP, You can enhance the existing decision process by taking into account your delay preference capacity index or whatever, but this should fit into the existing decision process. And the question also is, if you want to do that, another way could be to compute your cost at the egress and use the existing cost attribute in BGP to carry it.
That could be another way to do it, but the problem with that way, we have in the draft we did document that way. Okay, so the problem with that way is first of all, then all the algorithm, all the egress router has to be consistent. Second, you cannot differentiate which user, which input side it come from, because as an ingress router, he may need to have other informations in addition to the egress router running status, in addition to this cost matrix from R1. He may need other factors to choose, because, for example, in this for example, let's just talk about the router B, right? Well, router B, when he has the UE traffic coming to S1, if it's original UE, he will choose the S1 closest to him based on the routing distance or other conflictor matrix. But when there's a UE1 coming from 5G side A, re-anchored to PSA2, then this particular flow need to prefer to stick to the original server. Okay, so based on the source, he may need to forward it to a different server and maybe using a tunneling or maybe use the SR technology to send it to the egress R1. So the decision point should be considered that not only just the matrix themselves, the computer cost, there are other factors to be considered.
Fair enough, but again, if you are trying to modify the decision process, you have to comply with the existing BGP decision process and try to fit your additional inputs into the existing decision process. That's my comment.
Okay, we'll take that into consideration. Thank you very much.
Yeah, I heard the comment about hours, Linda. I wouldn't make a blanket statement about hours. Think about, 5G is not one use case, and you've got consumer, you have enterprise, and you have critical services, you have some of this stuff. So if don't build your solution out that the measurement is going to be in hours, because in some use cases that won't be helpful. So just keep that in mind.
Oh, thank you very much. That's a very good input. Thank you. Okay, next one. So this is about SD-WAN, totally different subject. Okay, so this is about SD-WAN edge discovery using BGP. Next page, please. So the intention of the draft is to use the tunnel in cap 20 and using the recursive lookup and to tag the client routes with extended community and also with the color extended community to make the update more compact. Next page. So the recursive lookup is described in the tunnel in cap section 8. So the client route basically have the next hop to the edge node loopback address. Then with instead of describing all the detailed tunnel attributes for this reaching this client, we're just using the encapsulation extended community with the tunnel type. We want to have a new tunnel type, SD-WAN hybrid, or other existing tunnel types. and we color it with specific color, extended community. And then the update 2 for the node will have the tunnel egress endpoint to describe which endpoint, which port this tunnel ends terminate, and we'll have the port sub-TOV, which include the ISP information for this port, particular WAN port, like whether it's from company A or company B. Will include geolocation of this node. Just assume that when SD-WAN deployment, they can be far apart in different countries or different states. The Lisp has this sub-TOV geolocation, which can be very useful to be included. And also optionally to include all the IPsec sub-TOVs. IPsec sub-TOV can be tricky because IPsec security associations are pairwise, meaning every node, between every node, they have different keys. So the attributes as defined in a secure EVPN, you can see is, there are many. Of course, they can be included, but also we could include security SA identifiers, which is pre-configured as well. Next page. Next page. So here's just the illustration of the recursive lookup. So you have this example, CPE2 has client routes 10.20. something, 30.1.1x. So for the prefix 10.1.1x and 20.1.1x, the next hop is 2222, which is CPE2, and they are colored with red. And it shows that they are hybrid, meaning that those routes can be carried by L3 VPN paths terminated at the CPE2, and also being terminated we have a one port provided by ISP1 192 port, and another port provided by the ISP2. Or you could be terminated by the loopback address, IPsec, terminated at the loopback address. So either of them will be fine, but here we don't have to specify that. Next page. Here is update 2, which describe the detailed attributes. So one way to do it, actually we presented at the BATH yesterday. We're just using the tunnel encap attributes with the new tunnel type SD-WAN hybrid, which can include all the needed information. And you will have the color, you will have the detailed endpoint sub-TOVs, you will have the IP sub-TOVs or IPsec SA IDs. That's one way to do it. But more optimized way will be able to is to create a new SAFI, SD-WAN SAFI, which has the color which are applicable to all the tunnel attributes carried by this update. Just make the update more compact. Also, you can have, like, if there's a specific tunnel need be colored differently, like purple, for example, only goes to CPE3. You can use this tunnel, you can use the color sub-TOV to further identify the specific tunnel. Next page. So this is for the SD-WAN hybrid SD-WAN hybrid tunnel type. You can here the you can include multiple underlay tunnels included in this. You can have list of IPsec SAs. You can have all those SA terminated at one endpoint, egress endpoint sub-TOV. And all those ports, all those IPsec SAs share the common port information. Next page, please. Alternatively, the IPsec attributes can be included. You include the IPsec essays nonce, public keys. You include the transform substructures, and those have detailed description in the Secure EVTPM. Though all those attributes can be included under the hybrid SD-WAN. In addition to existing tunnels, like for example, you may have NVGIE, or you may have IP in IP. All those can be included underneath this tunnel type. Next page, please. So with SD-WAN SASE, just to make the implementation easier, when the receiver receives the update, the color, SD-WAN color, will be applicable to all the paths, all the tunnels attached in this update, just like SR's color. Here are the detailed information underneath the hybrid SD-WAN tunnel type. Next page. For the SASE, SD-WAN SASE, we'll have two types. One is assuming that SD-WAN deployment is managed by one single company, or all their locators can be represented by local significant identifier. Another type is for large deployment, where you would require the geolocation sub-TLV to be included to uniquely identify the location. The geolocation sub-TLV is from the Lisp geolocation draft. You have a local ID, port ID, like suppose that you may have a group of CPEs there. They may have a local significant number to represent different port number. So that has a local ID. And then you have a coloring, which represent the common properties shared by all the tunnel attributes. Next page, please. So that's it. We'd like to hear your feedback. And in the draft, the more detailed description on the encoding of the nonce and essays and transform. So that is more details. I don't think we need to talk about them here.
Okay, well, we want your feedback. So anybody want to add themselves to the queue, or is it too late at night / early in the morning to dial into details about IPsec? That's where my brain is right now. Linda, thank you. Seeing the queue empty, I think that it's time for us to call it a night / morning / afternoon.
Thank you. Thank you very much.
Oh, AC? Oh no, he unmuted then remuted.
I was just
unmuted again.
/IETF 109.
Say it again.
/IETF 109.
Yeah, exactly. That's a wrap, everybody. Thank you very much. Get some sleep. Have a good day.
Yeah, thanks.
Yeah, good night.